Factoring trinomials of the form x squared plus bx plus c, and factoring out the GCF. Comparing multiplying with factoring. Multiplying and factoring are reverse processes. For example, when multiplying x plus 2 times x plus 3, our result is x squared plus 5x plus 6. When factoring x squared plus 5x plus 6, we get a result of x plus 2 times x plus 3. Factoring trinomials in the form x squared plus bx plus c. To factor x squared plus bx plus c, look for two integers p and q whose product is c and whose sum is b. That is, p times q equals c and p plus q equals b. If such integers exist, the factored polynomial is x plus p in parentheses, x plus q in parentheses. Factoring x squared plus bx plus c with positive c. To factor a trinomial of the form x squared plus bx plus c with a positive constant term c, if b is positive, then look for two positive integers whose product is c and whose sum is b. For example, x squared plus 10x plus 16, I have a positive c and a positive b. They have to multiply to be c. So my choices are 1 times 16, 2 times 8, and 4 times 4. These two numbers have to also add to be 10. 1 plus 16 is 17. 2 plus 8 is 10. 4 plus 4 is 8. So the only factor that meets both criteria, multiplying to be 16 and adding to be 10, is my 2 and my 8. So that gives us a result of x plus 2 and x plus 8. Both last terms are positive. In this example, factor x squared plus 11x plus 24. So we know we're going to have our two parentheses, and we know we're going to have x times x is x squared. So the hard part is 24. To multiply to be 24, I can use 1 and 24, 2 and 12, 3 and 8. I can use 4 and 6. They also have to add to be 11. 1 plus 24 is 25. 2 plus 12 is 14. 3 plus 8 is 11. And 4 plus 6 is 10. So the only two numbers that multiply to be 24 and add to be 11 are 3 and 8. To write them as our answer, since the 3 is positive, I put plus 3. Since the 8 is positive, plus 8. So my answer is parentheses x plus 3, parentheses x plus 8. Factoring trinomials of the form x squared plus bx plus c with positive c. To factor a trinomial in the form x squared plus bx plus c with a positive constant term c, if b is negative, look for two negative integers whose product is c and whose sum is b. For example, x squared minus 9x plus 18. I have a negative b but a positive 18. 18 I can multiply 1 times 18, or negative 1 times a negative 18, negative 2 times negative 9, negative 3 times negative 6. So when I add those, negative 1 plus negative 18 is a negative 19. Negative 2 plus a negative 9 is a negative 11. Negative 3 plus a negative 6 is a negative 9. The only two factors that multiply to be a positive 18 add to be a negative 9 are negative 3 times negative 6. So my answer is x minus 3, x minus 6. For this example, factor x squared minus 8x plus 16. So for 16, I need two numbers that multiply to be 16 but add to be negative 8. So I can multiply a negative 1 times a negative 16 to get 16, a negative 2 times a negative 8, or a negative 4 times a negative 4. To add those, negative 1 plus negative 16 is a negative 17. Negative 2 plus a negative 8 is a negative 10. And negative 4 plus negative 4 is a negative 8. So that means negative 4 times negative 4 is the only option that works. So in one parenthesis, I have x minus 4. In my other parenthesis, I have x minus 4. So my result is x minus 4 times x minus 4, or I can write my answer as x minus 4 parentheses squared. Factoring x squared plus bx plus c with c negative. To factor a trinomial in the form of x squared plus bx plus c with a negative constant term c, look for two integers with different signs whose product is c and whose sum is b. For example, x squared plus 2x minus 15, I have a negative c. My factors for 15 are 1 times 15 and 3 times 5. Now, to make those a negative 15, I would have negative 1 times a positive 15, or a positive 1 times a negative 15, a negative 3 times a positive 5, or a positive 3 times a negative 5. If I were to add these, negative 1 plus 15 gives me a positive 14. 1 plus negative 15 gives me a negative 14. Negative 3 plus a positive 5 gives me a positive 2. And 3 plus negative 5 gives me a negative 2. What I'm wanting is a positive 2. So I'm looking at a negative 3 and a positive 5. My answer is x minus 3, x plus 5. In this example, factor w squared minus 3w minus 18. First, we have to figure out what multiplies to be 18. We can have 1 times 18, 2 times 9, 3 times 6. Now the issue is we want a negative 18. So I can have a negative 1 times a positive 18, a positive 1 times a negative 18, a negative 2 times a positive 9, a positive 2 times a negative 9, a negative 3 times a positive 6, or a positive 3 times a negative 6. Then when we add them, negative 1 plus 18 is 17. 1 plus a negative 18 is negative 17. Negative 2 times 9 is 7. 2 times negative 9 is negative 7. Negative 3 plus 6 is 3. And 3 plus negative 6 is negative 3. Since we want our middle term to be a negative 3, 3 times negative 6 is going to be the factors we want. So I have my w and a positive 3, then my w and a negative 6. So my final answer is parentheses w plus 3 parentheses w minus 6. In this example, factor x squared plus 4x minus 21. My choices for 21 are 1 times 21 and 3 times 7. Because we need a negative 21, I can have a negative 1 and a positive 21, a positive 1 and a negative 21, a negative 3 and a positive 7, or a positive 3 and a negative 7. When I add, negative 1 plus 21 is 20. 1 plus a negative 21 is a negative 20. Negative 3 plus 7 is 4. 3 plus negative 7 is a negative 4. For our middle term, we need a positive 4. So we want to use negative 3 times 7. One parenthesis will have x minus 3. The other parenthesis will have x plus 7. So my final answer is parentheses x minus 3, and then my other parenthesis, x plus 7. Prime polynomials. Factor x squared plus 5x plus 10. Starting with the 10, I can get 10 by multiplying 1 times 10 and 2 times 5. My 5x is positive, so I can consider positives with my multiplication. Adding those, 1 plus 10 is 11, 2 plus 5 is 7. Neither of these match my middle term. So this polynomial is prime. Factoring out the GCF. The greatest common factor, referred to as GCF, of two or more terms is the monomial with the largest coefficient and the highest degree that is a factor of all terms. For this example, we want to factor 25x to the third plus 35x squared. I know that 25 can be written as 5 times 5, and x to the third can be written as x times x squared. Plus, I can write 35 as 5 times 7 times x squared. Both 25 and 35 have a factor of 5 in common. For x cubed and x squared, the greatest common factor is going to be x squared. So what I have in blue is my greatest common factor, 5x squared. What I have in green is what's left when you factor out 5x squared. If I start out with 25x to the third and I divide out 5x squared, I'm left with 5x plus. If I have 35x squared and I divide out 5x squared, I'm left with 7. 25x cubed plus 35x squared equals 5x squared in parentheses 5x plus 7. Completely factored polynomials. If a result cannot be factored further, it is said to be completely factored. In general, when the leading coefficient of a polynomial is positive and the GCF is not 1, first factor out the GCF. Don't forget to include the GCF as a part of your answer. When factoring a polynomial, always completely factor it. In this example, factor 3a to the fourth b minus 18a to the third b plus 27a squared b. Our first step is to look at our numbers. So I have a 3, 18, and 27. 3 is a factor of all of these. So the first part of my GCF will be 3. Now I want to look at my a. I have a to the fourth, a to the third, a squared. A squared is the smallest of these, so that's the next part of my GCF. Looking at b, I have b to the first, b to the first, b to the first, so the last part of my GCF is b. Now I need to figure out what would be left over if each term had 3a squared b divided out. One way to look at it is to picture it as 3a to the fourth b divided by 3a squared b. My 3's completely cancel, the b's completely cancel. A to the fourth divided by a squared, 4 minus 2 is 2. So my first term would be a squared. Now I'm considering my second term, which is negative 18 a to the third b, and I'm dividing out 3a squared b. Negative 18 divided by 3 is a negative 6. A to the second divided by a squared, 3 take away 2 is 1. And then the b's cancel. So my second term is minus 6a. Looking at my third term, I have 27 a squared b divided by 3a squared b. 27 divided by 3 is 9. A squareds cancel, the b's cancel, so my last term is 9. So I have 3a squared b parentheses a squared minus 6a plus 9. Now what I want to do is look at my a squared minus 6a plus 9 to see if that can be factored further. I can get 9 by multiplying 1 times 9 or 3 times 3. I need a negative for my middle term, so it would be a negative 9, negative 1, negative 3, negative 3. If I were to add those, negative 1 plus negative 9 is a negative 10, and negative 3 plus negative 3 is a negative 6. This one does match, so last step, I bring down my GCF, open parenthesis, a minus 3. My second parenthesis is also a minus 3. So my answer is 3a squared b times a minus 3 times a minus 3, or I can write it as 3a squared b parenthesis a minus 3 close parenthesis squared. Leading negative coefficient. Factoring when the leading coefficient is negative. When the leading coefficient of a polynomial is negative, first factor out the opposite of the GCF. For this example, I want to factor negative 5x squared y plus 15x y squared minus 10y to the third. Since my first term, negative 5x squared y, I have to factor out that negative. Now looking at the 5, the 15, and the 10, I can see they all share a factor of 5. Looking at x squared, x, and nothing, can't factor out an x. Looking at y, y squared, y to the third, my smallest exponent for y is y to the first. So my greatest common factor is negative 5y. Negative 5x squared y. What would that look like if I divided out negative 5y? My negative 5's would cancel, my y's would cancel, leaving me with a positive x squared. Now I have a positive 15xy squared. What would that look like without the negative 5y? 15 divided by negative 5 is negative 3. I can bring over my x, and y squared divided by y to the first is just y. Looking at negative 10y to the third, dividing out negative 5y, negative 10 divided by negative 5 is going to give me a positive 2. And then y to the third divided by y to the first is going to give me y squared. So I have negative 5y parentheses x squared minus 3xy plus 2y squared. I need to double check to make sure this can't be factored any further. My factors for 2 are 1 times 2. To get a negative middle term, it'd have to be negative 1 times negative 2. If I add negative 1 plus negative 2, I get negative 3. So I can factor this again. Bring down my negative 5y. In one parenthesis, I'll have x minus 1y, or just y. In my other parentheses, I'll have x minus 2y. So my final answer is negative 5y parenthesis x minus y parenthesis x minus 2y. I can check my answer by doing FOIL first, then distributing. Factoring trinomials in the form x squared plus bx plus c. You want to look at the value for c and try to find all the numbers that multiply to give you c. If your c is positive, you'll be able to choose between two positive numbers or two negative numbers. If it's negative c, then one of the numbers will be positive, the other will be negative. Add up your possibilities and pick the one that results in your value for b, including the sign. Greatest common factor is a number, a variable, or a combination of numbers and variables that are common to all of the terms. Once you factor out your greatest common factor, it's a little easier to factor the trinomial into two parentheses if that is possible. A polynomial is completely factored when the greatest common factor has been factored out and it has been factored into at least two parentheses, sometimes more. When you have a leading negative coefficient, you need to factor that out as well so that your first term will be positive.